Look up at the night sky for a moment. Every star you see, every glowing nebula, every distant galaxy shining across billions of light years feels unimaginably vast. Yet what if all those brilliant lights together represent only a tiny fraction of what actually exists in the universe? Astronomers have discovered something deeply unsettling. When they measure the gravity holding galaxies together, the visible stars and gas simply aren't enough. Something else, something completely invisible, appears to be filling the cosmos and shaping the motion of entire galaxies. This mysterious substance doesn't shine, doesn't reflect light, and passes through ordinary matter almost like a ghost. Yet its gravity quietly controls the structure of the universe itself. In fact, scientists believe this hidden material may make up most of the matter in existence. So what exactly is this invisible mass? Why does it seem to surround galaxies everywhere we look? And how did something we can't even see end up shaping the entire cosmic landscape? To answer those questions, we're going to journey across the universe, from tiny invisible particles to the birth of galaxies themselves, to uncover one of the greatest mysteries in modern science. Astronomers have spent decades measuring the mass of galaxies, mapping the motion of stars, and weighing the universe in every way they can imagine. Yet again and again, something puzzling shows up in the numbers. The gravity they observe seems far stronger than the gravity that visible matter alone could produce. It's as if the universe is hiding enormous amounts of unseen mass. Picture a giant cosmic merry-go-round made of billions of stars. According to the gravity created by visible matter, the outer stars and galaxies should spin more slowly, almost like children drifting outward on a playground ride that's losing speed. But that's not what astronomers see. Instead, those distant stars keep racing around their galaxies far faster than expected. It's a bit like watching a spinning top that should have slowed down long ago, but somehow keeps spinning with surprising strength. The visible stars, gas and dust, simply don't add up to enough mass to hold everything together. Something unseen must be providing extra gravity, quietly shaping the motion of entire galaxies. And this mystery doesn't appear in just one galaxy or two. It shows up everywhere scientists look, across the vast ocean of the cosmos. That realization leads to a stunning possibility. Perhaps most of the matter in the universe is invisible. So the question slowly emerges, echoing across the halls of astronomy. If we can't see this matter, what exactly is it? And how did scientists first realize that this hidden mass might be filling the universe itself? Once astronomers began to suspect something invisible was shaping galaxies, they started looking for clues across the universe. And the deeper they looked, the stranger things became. The evidence didn't appear in just one place. It appeared everywhere, almost as if an unseen ingredient was woven into the very structure of the cosmos. One of the first clues came from how galaxies rotate. If gravity came only from visible stars and gas, the outer edges of galaxies should move more slowly, just like planets in our solar system take longer to orbit when they're farther from the sun. But when astronomers measured the motion of stars near the edges of galaxies, they found something astonishing. Those distant stars weren't slowing down at all. They were moving almost as fast as the stars near the center. It's like watching a spinning pizza dough where the outer crust somehow keeps up with the center instead of lagging behind. That kind of motion requires far more gravity than visible matter can provide. But the clues didn't stop there. When astronomers observed massive clusters of galaxies, collections of hundreds or even thousands of galaxies bound together, they discovered that these clusters were held together by far more gravity than their visible matter could explain. Then there's another extraordinary piece of evidence involving light itself. When light from distant galaxies travels through the universe, massive objects bend its path, almost like a cosmic magnifying glass. This effect, known as gravitational lensing, often reveals far more mass than telescopes can actually see. Together, these observations form a powerful pattern. Galaxies rotate too fast, galaxy clusters stay bound too tightly, and light bends too strongly. All signs point to the same unsettling conclusion. Most of the universe's mass might be completely invisible. But if this mysterious substance surrounds galaxies and fills the cosmos, the next question becomes even more fascinating. What could this invisible matter actually be made of at the smallest scale of nature? Now the journey shifts from the grand scale of galaxies to the tiniest realm of physics. If dark matter truly exists everywhere in the universe, it must ultimately be made of something, some kind of particle hiding deep within the fabric of reality. But here's where the mystery deepens. Whatever these particles are, they behave very differently from the matter that forms stars, planets, and people. Ordinary matter interacts with light all the time. Atoms absorb, emit, and scatter light, which is why we can see objects around us. But dark matter seems to do none of that. It neither shines nor reflects light, making it completely invisible to telescopes. Imagine billions of tiny particles streaming through space like an invisible wind. These particles could be passing through Earth, through mountains, through oceans, even through our own bodies right now, without leaving any noticeable trace. Unlike ordinary matter, they would barely interact with atoms at all. Scientists believe these particles would move through matter almost like ghosts, passing through walls. A useful comparison might be neutrinos, which are real particles known to pass through the entire Earth almost effortlessly. Dark matter particles may behave in a similar way, but with one crucial difference. They would carry mass and therefore create gravity. Because they interact so weakly with normal matter, detecting them is incredibly difficult. It's like trying to catch a single grain of sand in a hurricane made of invisible particles. Even the most advanced instruments struggle to notice even the faintest sign of their presence. Yet if these particles are flowing through the universe everywhere, a natural question begins to emerge. If dark matter fills space, why doesn't it seem to influence the motion of planets, moons, and objects here within our own solar system? After hearing that dark matter may fill the universe, a natural thought comes to mind. If this invisible substance is everywhere, shouldn't it be affecting the motion of planets, moons, and spacecraft here in our own solar system? After all, gravity shapes everything from falling apples to orbiting worlds. So where is dark matter hiding on the scales closest to home? The surprising answer is that, on planetary scales, dark matter barely makes a difference. The reason lies in how thinly spread it is. Even though dark matter may dominate the mass of entire galaxies, its density in any small region of space is incredibly tiny, far smaller than the mass contained in stars, planets, and dust. Think of it like a faint cosmic mist drifting through space. Imagine standing inside a vast fog where the droplets are so sparse that you barely feel them on your skin. In a similar way, dark matter may be passing through our solar system constantly, but the amount present here is so small that its gravitational influence is almost impossible to notice. Instead, the motion of planets is governed almost entirely by visible matter, especially the sun. Its gravity dominates the solar system, guiding planets along their stable orbits, much like a spinning skater pulling nearby objects into a smooth circular dance. Compared to that powerful influence, dark matter is simply too diluted to compete. So while galaxies depend on dark matter's gravity to stay together, our local cosmic neighborhood is shaped almost entirely by familiar forces. But that raises an intriguing question. If dark matter is so hard to detect and barely interacts with ordinary matter, how do scientists even attempt to find it? Somewhere on Earth, deep underground and far from cosmic noise, scientists are building extraordinary experiments designed to catch the faintest whisper of this invisible substance. If dark matter rarely interacts with ordinary matter, detecting it becomes one of the greatest challenges in modern science. Scientists can't simply point a telescope at it or capture it in a photograph. Instead, they must design experiments capable of noticing the faintest, rarest interactions imaginable, events so subtle they might occur only once in months or even years. To make this possible, physicists build detectors deep underground. These laboratories are often placed beneath mountains or inside abandoned mines, where thick layers of rock shield the instruments from cosmic radiation and other interfering particles. Down in the quiet darkness, incredibly sensitive detectors wait patiently for a tiny signal. Inside these detectors are tanks filled with special materials such as liquid xenon or ultra-pure crystals. If a dark matter particle happens to collide with an atom inside the detector, the atom might produce a minuscule flash of light or a tiny vibration. It's a bit like setting up a perfectly still pond and watching for the smallest ripple. The challenge is that these ripples are incredibly rare. Imagine leaving a bell in the middle of a vast desert and waiting for a single grain of sand to strike it. That's the level of patience required in the search for dark matter. Yet scientists continue listening carefully, hoping that one unmistakable signal will reveal the nature of this invisible substance. But underground detectors are only part of the search. Space telescopes scan the cosmos for unusual signals, while particle accelerators attempt to recreate the extreme conditions where unknown particles might appear. Each experiment acts like a different net cast into the ocean of the universe. And all these efforts point toward a deeper scientific idea. Even though dark matter remains invisible, its gravitational influence is undeniable. Understanding how gravity reveals its presence brings us to one of the core principles behind this cosmic mystery. At the heart of the dark matter mystery lies one simple but powerful force: gravity. Gravity doesn't care whether something shines, reflects light, or remains completely invisible. If an object has mass, gravity will reveal its presence. In many ways, gravity acts like the universe's most honest detective, quietly exposing hidden matter through its effects. Imagine watching leaves swirling in a gentle whirlwind. Even if you couldn't see the wind itself, the motion of the leaves would reveal that something invisible was moving through the air. Astronomers use a similar method when studying the universe. By observing how stars and galaxies move, they can infer the presence of unseen mass shaping those motions. This is exactly how dark matter reveals itself. Although it does not emit light or interact strongly with atoms, its gravitational pull subtly guides the motion of stars, galaxies, and even vast clusters of galaxies. The universe, in a sense, leaves footprints of dark matter everywhere through the movements of cosmic objects. Gravity also bends space itself. According to modern physics, massive objects warp the fabric of space and time around them, much like a heavy bowling ball placed on a stretched rubber sheet. Even if dark matter is invisible, its mass still bends this cosmic fabric, influencing how objects and light travel through the universe. When astronomers map these distortions and motions, they consistently discover far more gravity than visible matter alone can produce. It's as though galaxies are sitting inside enormous invisible cocoons of mass, structures that extend far beyond the stars we can see. And these hidden structures didn't just appear recently. To truly understand their role, scientists must travel back in time to the earliest moments of the universe, when the first cosmic structures were beginning to form. To understand how dark matter shaped the universe, scientists must rewind the cosmic clock billions of years, back to a time when the universe was still young. In those early ages, matter had not yet organized itself into the galaxies and stars we see today. Instead, the cosmos was filled with vast clouds of gas slowly drifting through expanding space. But these clouds did not collapse randomly. Something invisible was already shaping the universe's architecture. Dark matter, spread throughout space, began gathering under the influence of gravity, forming enormous regions of concentrated mass. These invisible structures acted like a gravitational framework for the entire cosmos. You can imagine it like the scaffolding of a building under construction. The scaffolding itself may not become part of the finished walls, but it guides where everything else forms. In a similar way, dark matter created invisible gravitational wells where ordinary matter, gas made of hydrogen and helium, could begin to collect. As gas fell into these gravitational pockets, it started to swirl and compress. Over time, these collapsing clouds ignited the first stars, which later grouped into galaxies. Inside one small region of one such galaxy, billions of years later, a swirling disk of gas and dust would eventually give birth to our own solar system. Within that spinning disk, gravity pulled material together to form the sun at the center. Around it, leftover dust and gas gradually clumped into planets, moons, and asteroids. The same gravitational rules that guide spinning tops and orbiting planets began shaping a new planetary family. So while dark matter does not directly shape the motion of planets today, its influence may have helped build the cosmic structures that allowed stars, and eventually solar systems like ours, to form in the first place. And that realization leads to an even more profound thought. If dark matter helped build galaxies, it may also have helped create the conditions that allowed life on Earth to exist. At first glance, dark matter seems far removed from everyday life. It floats invisibly through galaxies, rarely interacting with ordinary matter, and leaves no trace that human senses can detect. Yet when scientists trace the chain of events that led to our existence, dark matter quietly appears at the very beginning of that cosmic story. Without dark matter, galaxies might never have formed in the way they did. In the early universe, ordinary gas alone may have struggled to collapse quickly enough to build the first large cosmic structures. Dark matter's gravity acted like a silent organizer, helping gather matter into the enormous regions that eventually became galaxies. You can imagine it like seeds forming inside a swirling storm. In a hurricane, tiny variations in pressure guide the movement of air and water, shaping the storm's structure. In a similar way, dark matter created gravitational seeds that helped matter gather into stars and galaxies across the universe. Inside galaxies, stars were born, and around some of those stars, planets slowly formed from disks of dust and gas. Over billions of years, one of those planets, Earth, developed oceans, an atmosphere, and eventually life capable of looking up at the sky and wondering how it all began. So, in an indirect but profound sense, dark matter may have helped create the cosmic environment that made our existence possible. Without the gravitational scaffolding provided by this invisible substance, the universe might have looked very different, perhaps too chaotic for stable galaxies and planetary systems to form. And when astronomers zoom out again to the scale of entire galaxies, they find that dark matter is still there, surrounding them like enormous invisible halos that stretch far beyond the stars themselves. When astronomers zoom out to the scale of entire galaxies, the influence of dark matter becomes impossible to ignore. Stars, gas clouds, and glowing nebulae form the bright structures we see in telescope images. Yet these visible components appear to be only a small fraction of the true mass surrounding a galaxy. In fact, galaxies are thought to sit inside enormous spheres of invisible matter known as dark matter halos. These halos stretch far beyond the outermost stars, extending deep into intergalactic space. Like an invisible cocoon, this hidden mass wraps around galaxies and holds them together through gravity. Imagine a spinning carousel where the visible horses represent stars. If only those horses carried weight, the outer ones would eventually fly off as the ride spins faster. But if a massive invisible frame surrounds the carousel, it provides the extra stability needed to keep everything moving together. Dark matter halos play a similar role in galaxies. Their gravity helps prevent fast-moving stars from escaping into deep space. Without this invisible support, many galaxies might slowly unravel over cosmic time, losing stars from their outer regions. These halos also influence how galaxies interact with each other. When galaxies pass close together, their invisible dark matter halos collide and merge long before their visible stars do. This hidden interaction shapes how galaxies grow, merge, and evolve across billions of years. And when scientists look even farther back in time, toward the earliest moments after the universe began, they discover that dark matter may have been one of the first ingredients shaping the cosmic landscape. To truly understand why dark matter seems to be everywhere, scientists look back to the earliest moments of the universe. Just after the Big Bang, the cosmos was an incredibly hot and dense ocean of particles and energy. Everything was mixed together in a rapidly expanding space that had not yet formed stars, galaxies, or planets. As the universe cooled, particles began to slow down and gravity started shaping the first structures. Dark matter, unlike ordinary matter, did not interact strongly with radiation or light. Because of this, it was able to begin clumping together earlier, quietly forming the first gravitational seeds of cosmic structure. Imagine rainwater collecting into small puddles across a landscape. Once those puddles form, more water naturally flows toward them, deepening the pools. In a similar way, dark matter created tiny regions where gravity was slightly stronger, allowing more matter to gather there over time. Ordinary matter, mostly hydrogen and helium gas, eventually followed these gravitational pathways. It flowed into the invisible dark matter structures like mist settling into valleys. Over millions of years, these regions grew larger and denser, eventually igniting the first stars and assembling the earliest galaxies. As galaxies merged and expanded, these dark matter structures continued growing as well. They formed a vast cosmic web stretching across the universe, connecting galaxies and clusters through enormous filaments of invisible mass. And yet, despite playing such a crucial role in shaping the universe from its very beginning, dark matter remains completely unseen. Which brings us to one final thought. If most of the universe's matter is invisible, what does that say about the limits of what we truly understand? As the cosmic picture comes into focus, one realization becomes impossible to ignore. Everything humans have ever seen, every star, every planet, every glowing galaxy, represents only a small fraction of the universe's matter. The vast majority may exist in a form that remains completely invisible to our eyes. It's a humbling thought, For thousands of years, people studied the night sky believing the visible stars represented most of what existed. Yet modern discoveries suggest that the universe is largely made of something hidden, something that neither shines nor interacts with light in any familiar way. Imagine walking through a dark forest at night with only a small flashlight. The beam illuminates a few trees and rocks nearby, giving the impression that the forest is mostly empty. But beyond the edge of that narrow light lies an enormous landscape still concealed in darkness. In many ways, humanity's knowledge of the cosmos may be similar. Our telescopes and instruments reveal astonishing details about stars, galaxies, and nebulae. Yet dark matter reminds us that much of reality may still lie outside the reach of direct observation. The universe, it seems, is not only vast, it is also deeply mysterious. And as scientists continue searching for the true nature of dark matter, they are really exploring a deeper question about existence itself. How much of reality is still waiting to be discovered?